of cubing a number is to take its cube root. The inverse of a square is to take the square root, right? If two functions are inverse, they consist of inverse operations performed in the opposite order, okay? So what is the inverse of the relationship described here? F of x equals x plus 1. If you watched your do now video, he gave you some steps to follow when you're finding the inverse, right? So step 1 is we're going to switch x and y. So x and y are going to switch places. Remember, f of x is just a fancy way of saying y. So we end up with x equals y plus 1. It's going to show at some point. Now, show it. Go. I've written x equals y plus 1, and I don't know why it's not showing it. There we go. All right, so we know that x equals y plus 1. That's step 1. Step 2 is to solve for y. So you're going to use inverse operations to solve for y. So you're going to do whatever you need to do to get y by itself. So looking here, what would I need to do to get y by itself? Subtract 1, right? So I subtract 1 from both sides. So I have x minus 1 equals y plus 1 minus 1. This is going to cancel out, and I'm left with y being by itself. And the last and final step is to rewrite it using inverse. So we rewrite using inverse notation. So we write f to the negative 1 or y to the negative 1, just to show that that's the inverse. So our answer here would be to start off f of x. So f inverse of x equals x minus 1. Does that seem terrible? So we switch x and y, we solve for y, we rewrite. Okay. Let's deal with the word problem. So it says here, the function d equals 4 9/10 t squared represents the distance d in meters that an object falls in t seconds due to Earth's gravity. Find the inverse of this function. How long in seconds does it take for the cliff diver shown to reach the water below? So there's two parts. So part 1 is we're going to find the inverse of the function. And then part 2, we're going to use the inverse to answer the question. So right now the function is defined by the distance, right? And by time. And it's going to tell us the distance. We want to define it by time to find define it by distance so that we can know what the time is. Okay. So we have d equals 4 9. That's a 9 t squared. Step 1 tells us to switch our independent and dependent variable. So when we switch them, we end up with t equals 4 9/10 d squared. So we switched our independent and dependent variables. How do you feel about the switch? Okay. Step 2 says to solve for that variable. So now we're solving for d. So what do I need to do to get d by itself? It's multiplication, right? What's the opposite of multiplication? Divide. So I'm going to divide by 4 9/10. And what I do to one side, I have to do to the other. So we're left with t over 4 9/10 equals d squared. Is d by itself yet? It is?
Oh, no.
All right, what's the last thing I need to do to get d by itself? take the square root, because the opposite of squaring is to take the square root. So we're going to take the square root of the numerator and the denominator. Or just leave it all as a square root, in all honesty. And now this cancels out. So now we know what D is. So we're going to rewrite. Because these are defined variables already as D and T, we don't have to worry about writing inverse. So we now just know that D equals the square root of T divided by 4 9/10. Not D, I wrote that wrong. I'm sorry. We now solved. They switched roles, T and D. It's like I wrote that back. So now our roles are back. T is our dependent, D is our independent. So this is the function we're working with. And now let's answer the question. How long in seconds does it take for the cliff diver shown to reach the water below? Well, how far does the cliff diver have to go? 24 meters, right? So that means all I have to do is plug in 24 to find its time. So we have T equals the square root of 24 divided by 4 9/10. I'm going to pull out my handy dandy calculadora. All right, so I'm going to do my division, then my square root. So I have 24 divided by 4 9/10. And then I'm going to take the square root of that. And it gives me 2 and 20, roughly 2 and 21/100. Is it okay if I cut off right here? Okay, so let's repeat what I did. All I did was do the math. 24 divided by 4 9/10. Then I took the square root. And I got 2 and 21/100. So how long will it take for him to fall? 2 and 21/100 seconds. Okay, so in all honesty, did you have to find the inverse to answer this question? No. Could you have plugged in 24 from the beginning and just did the inverse? Yes, you could have. You could have just plugged in 24, divided, took the square root, call it a day. But I wanted to practice making sure we could find the inverse. Because what if it's not just 24? What if it's okay, what about 56? What about 36? What about all these other distances? If I have a formula where I could just plug in the distance and not have to redo that process every single time, that's what makes it easier, okay? This one, it's a one problem, so I could have just plugged in and solved, but just wanted to make sure we're okay and that we're comfortable understanding that the inverse of a square is the square root. All right, so what we're gonna do is we're gonna do a couple practices together. We're gonna start off, I'm gonna give you time to do it, and then we're gonna go through it together to see how well you did it. The first one we have here is y equals, it's kind of hard, y equals 3/2 x minus 2. And I want you to find the inverse of it, and then we're going to go over it. So I'm going to give you a couple minutes to start here. and then we'll go over it. Okay, so the first thing you should have done was switch your X and your Y. So now you have X equals 3/2 Y minus 2. Step 1. Step 2 is to get Y by itself. So I'm going to add 2 to both sides. That's going to give me X plus 2. That's not a 2. Equals 3/2 Y. Y is still not by itself. So how do you cancel out a fraction? I'm glad you asked. You cancel out a fraction by multiplying by its reciprocal. So instead of 3/2, it becomes 2/3. And that's how you cancel out a fraction. And what you do to one side, you do to the other. So now Y is by itself. So step 3 is to rewrite it. So we have the inverse equals. And you can distribute it or leave it as is. I really don't care. So you have 2/3 X plus 2, or you can write it as 2/3 X plus 4/3. Remember, when you distribute a fraction times a whole number, it's the numerator times the whole, which makes it 4/3. All right, questions about number 1? How did y'all do on number 1? Yeah, okay. Let's try number 2. So number 2, we'll start together. Remember, you're switching your X and your Y. That's step 1 to switch. So when you switch, you have X equals 3Y squared plus 2. Step 2 is to get Y by itself. So what do we need to do to get Y by itself? Subtract the 2, exactly. And we have X minus 2 equals 3Y squared. And you want to keep trying to get Y by itself? Is Y by itself yet? No. So what's the next thing I need to do? It's a multiplication. Divide 3. So I'm going to divide everything by 3. So now we have this, and Y still not by itself. I'm going to have to take the square root. So now Y is by itself. So my inverse equals. And when you take the square root of something, it's going to create a plus or minus. X minus 2 over 3. Okay, let's try number 3. So number 3, we have Y equals the square root of X plus 4. So we have the square root of X plus 4. First step to do is to switch the X and the Y, right? So we switch them and we get X equals the square root of Y plus 4. Next, we're going to get Y by itself. What is the first thing I need to do to get Y by itself? Subtract the 4. Good job. So we have X minus 4 equals the square root of Y. What is the inverse of square root?
Oh, square.
Square. Okay, when you square, be careful. You have to include parentheses because the square applies to all of the terms. So Y is now by itself. It's happy. So our inverse equals X minus 4 squared. All right, questions? Okay, so I would like for you to try the last 3 and then we'll check them, okay? All right, let's talk about what we got. So on number 4, you notice that you had division. And what's the opposite of dividing? Multiplication. So before you do anything, you had to remove the division. So you should have multiplied both sides by 2. And then you were left with 2x equals y minus 1. And the inverse of subtracting 1 is to add 1. So we add 1 to both sides. Y is now by itself. So that's our inverse. Y inverse equals 2x plus 1. Questions about number 4? Number 5, you switched your independent and dependent, your x and your y. The opposite of taking the square root is to square. So you should have squared both sides. After you squared both sides, you were left with x squared equals y plus 2. The opposite of adding 2 is to subtract 2. Y is now by itself. So your inverse equals x squared minus 2. All right, number 6 would probably be the toughest of the bunch. So you switch your x and your y. You start off with the multiplication. So the opposite of multiplying is to divide. So you should have divided by 2. So that would have given you x divided by 2. After you divided by 2, you had to get rid of the square. So the opposite of squaring something is to take the square root. When you take the square root of something, it's going to create a positive and a negative. And we were left with y minus 5. The opposite of subtracting 5 is to add 5. So we added 5. And we're left with the inverse equals positive 5 plus or minus the square root of x divided by 2. All right, and that concludes our notes. Please stay in your seats until the bell is going to ring in about 30 seconds. So to start off with, do you guys remember the horizontal line test and the vertical line test from Algebra 1? Ringing some bells? Yeah? Okay, so the vertical line test, I'm going to write VLT for vertical line test, passes. That means it's a function, right? Means it's a function. Okay, yes. If it passes VLT and the horizontal line test, that means it's that's a lot of humps in my M's, just go with it. Means that it's a 1-to-1 function. Okay, do those ring bells? Okay, so the deal is the quadratic function, f of x equals x squared, it passes the vertical line test, but it does what with the horizontal? It fails the horizontal line test, right? So what that means is that its inverse is not a function. And that's why when I told you yesterday, when we take the square root of something and it creates this plus or minus, it means that it's a relation, not a function, okay? In order for the quadratic to have an inverse, it must have a restriction. So instead of us looking at the whole quadratic, we only look at the positive half. And that's why we say, okay, we're analyzing x squared, but only where x is greater than or equal to 0. Relation. Okay, and so now this passes, so this will pass vertical line test and horizontal line test, which means that its inverse is a function. So what we're going to talk about today is domain and range and how the restrictions work for square root and quadratics. Okay. All right, let's dive in. I don't know why my highlights didn't go away. I don't know, it's just gonna be highlighted. Cool, I'll write over them. All right, so my thing got a little weird. This should say we're examining the graphs, and the graphs are, yours are fine. You have f of x equals the square root of x plus x minus 2, right? And then your inverse function should say x squared plus 2, right? So yours should have printed out pretty and right. However, mine came out weird. All right, so we're going to analyze each one of these, their domain and their range. So the domain of our f of x, remember domain is from left to right. So reading from left to right, where do I start on the x-axis? I start at 2, right? And I go forever to the right, which is positive infinity. So my domain is from 2 to infinity, okay? That's interval notation. And inequality notation, that means that x is greater than or equal to 2. Ringing bells? Okay. My range is bottom to top. So if I'm here at 2, 0, where does my range start at? What's my lowest y value? Lowest y value is 0, and then it goes to infinity. So 0 to infinity. That's my interval notation. And my inequality notation would be y is greater than or equal to 0. Do we remember doing domain and range? Still with me? Okay. Now we're going to do domain and range of our inverse. So looking at the inverse, the domain and range here. So domain starting from left to right, I'm here at 0, 2. So what is my smallest x value? 0. And the arrow means it goes on forever. So the domain here is x is greater than or equal to 0. The range, what is my smallest y value? 2. And it keeps going forever to infinity. So y is greater than or equal to 2. Okay, does that feel familiar? No one feels like that's brand new, right? All right, so now let's pay attention. Let's notice that the range of our function and the domain of our inverse function are what? The domain, the range of our function and the domain of our inverse are what? The same, right? They're the same. The same. And when you look at the domain of our original function and the range of our inverse, what do you notice? The same. So what that means is that, in summary, for all functions, domain of f of x is the range of the inverse. And that's because yesterday when we were finding the inverse, what was the very first thing we did? What's the very first thing you do when you're finding the inverse of a function? You switch, right? You switch the x and the y. And what does x and y represent? Your domain and your range. So you're switching their values. You're switching what they are. Okay, so if I know the domain and range of my inverse, then I know the domain and range of my function. If I know the domain and range of my function, I know the domain and range of my inverse. Does that make sense? All right, so let's do one example together and we'll keep it pushing. So here we have the original function, f of x equals 3 minus x, the square root of 3 minus x. So the domain of this function, so starting from the left, this function is heading towards negative infinity. Agreed? So it starts at negative infinity. That's I wrote double negative. And the biggest the x values will ever get is what? 3, right? So my domain is x is less than or equal to 3. My range from bottom to top, what is the function doing? What is my lowest y value? What's my lowest? Uh-oh. 0. So I start at 0, but my y's are continue to grow and heading towards infinity. So my range is y is greater than or equal to 0. So knowing that, what would be the domain of my inverse? Which one of these tell me my domain? The range. The range tells me my domain of my inverse. So the domain of my, yes.
Is there a difference between like infinity and negative infinity?
Yes. Infinity on the y means you're going up, and infinity on the negative means you're going down. On the x, infinity, positive infinity means you're going to the right, and negative infinity means you're going to the left. It happens to the best of us. All right. So the range of the function tells me the domain of my inverse. So we're at 0, infinity, and it's describing our x now instead of our y. And the domain of our function tells us the range of our inverse, which is negative infinity to 3. And it's describing our y's now instead of our x. Okay. All right. Doable? All right. So that is your 6.3b. So through composition. We did composition in the first 6 weeks of school, but we only did it with numbers, not with functions. Now we're doing it with a function. So basically, that's where you plug a number into one function, then the answer of that one into the next one, right? So basically, you know how people are like, oh, you can't turn apples into oranges? Ha 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 ha. Yeah, you can with composition. So with composition, it's saying you take your apples, you're gonna plug it into the first function. They make a whole new thing. We're gonna call them lemons. Then you take the lemons and you're gonna plug them into the other function, and wham, bam, thank you, ma'am. You somehow have oranges. Okay, that's how composition works. Okay, now why is composition important? Because it lets us know if two functions are inverses of each other. So if I take f of x and I substitute g of x in, and I get x. Or if I take g of x and I substitute f of x in and I get x, that means the two functions are inverses. And it sounds weird, but
Ain't you recording me, Joe? Miss Joe, where did this go?
at the top of your page somewhere.
Oh.
All right, so that's our goal. We're gonna verify whether substituting g of x into f equals x and substituting f of x into g equals x. If they do, then they are inverses. If they don't, then they are not, okay? So here we go. We have x squared plus 7 with a domain restriction. The domain restriction lets us know that the inverse is a function, if it works. Now, if we have the quadratic with no domain restriction, no bueno. Because that means it wouldn't be a function, it would just be a relation. So we're going to split this in half. We're going to do f of g of x on one side, and we're going to do g of f of x on the other side. Huh? So g of x, what does g of x equal? It equals the square root of x minus 7. So we're substituting in the square root of x minus 7 everywhere that there's an x. Okay, so that equals square root of x minus 7 squared plus 7. All right. What does the square and the square root, what is their relationship? What do they do to each other? They cancel out because they're inverses, right? So this is going to go away, and we're just left with x minus 7 plus 7. What happens to negative 7 and positive 7? They cancel out. So we're just left with x. So what does that mean about f of x and g of x? That they are inverses. That's what that means. When it's just x left, that means that they're inverses. Okay, and you could do it either as f of g of x or g as f of x. So doing it the other way, this time we're plugging in f of x in for x of g of x. So g composed of x squared plus 7 equals the square root of x squared plus 7 minus 7. I have a positive 7 and a negative 7, so they.
So if it's x squared, is that an inverse too?
So we have square root and x squared, and what do they do? Cancel out, and what are we left with? X. So what does that verify again? That they are inverses.
So Ms. Jones,
Yes,
the
yes.
answer will never be x squared.
It can be, and if it is x squared, then that means they are
Inverse.
not inverses.
I asked you that, you said they was
If it comes out to be x,
x squared.
No, it has to just be x. Only x. You confuse me. All right, so I would like for you guys to try this one. So choose either one. So choose whether you're going to use f composed of g of x or g composed of f of x.
Also, we can choose either.
Yes. Okay, I'm going to be a nice person this year, and yes, normally I would make you do both. So here, we're substituting in g of x, which is the square root of x plus 1, which equals, where x is, it now becomes parentheses, square root of x plus 1 minus 1 squared. Your ones cancel out, and you're left with square root of x squared. Your square and your root cancel out, and you're left with, so are they inverses? Yes. Good job. Now, just in case someone does this one, you're substituting f of x, so this guy. And that's x minus 1 squared being substituted in. So you have the square root of x minus 1 squared plus 1. This time, the root and power cancel out first. And you're left with x minus 1 plus 1. Then your ones cancel out. And you're left with x. So either way, are they inverses? Yes. How do you feel about verifying inverses? Doable? Okay, cool. So the last three, we're going to apply 6A, 6.3a and 6.3b notes. Okay, we're gonna do the other ones first, the first part first together, and then you're gonna find the inverse and find the domain and range of the inverse, okay? But we're gonna find the domain and range of the current function together using our previous skills. Cool? So we're gonna start here with number 1. So number 1, we have y equals x squared minus 6, okay? Because I have x squared minus 6, I know that this is a quadratic, and it looks something like this, right? Because my a is positive. Now, in order to find the domain and range of a quadratic, you need to know its vertex. So we're going to have this this quadratic, and its vertex is based off of its h and k. If I do not have an h, what does that mean the value of my h is? 0. What is my k? -6. So my vertex is at 0, -6. In order for this to have a inverse, there has to be a domain restriction. So what is the smallest my domain can be? 0. And then it continues to infinity. My range would be what? What's the smallest my range is? -6 to infinity. Okay. And then I'm gonna pause and let you guys do the inverse and the domain and range of the inverse. Okay. I'm gonna pause and then we'll come back. All right, so once you have the original, you then can talk about the inverse. So the inverse here, remember, that's you switching your y and your x. And when you switch your y and your x, you're asking yourself, what do you need to do to get y by itself? So we have x equals y squared minus 6. So in order to get y by itself, to get my inverse, that means we are adding 6 and we're taking the square root. Okay, and so that this is a function, we're going to have restrictions, and our domain and our range is based off of our original. So the domain here comes from the range of the original, which is -6 to infinity. And our range here comes from the original, which was a restricted domain of 0 to infinity. Okay. Okay, now pause, and you're going to try to do number 2. Thank you for pausing. Now we're back. So we're going to look at the original. This is a square root function. So square root functions don't have a vertex necessarily. They have a starting point. So where does this square root function start at? Well, based off of your h and your k, it starts at 0, 2, and our a is positive, so it's doing this. Could you graph it and see that? Yes, you could. The domain here, the domain starts at 0 and goes to infinity. The range here starts at 2 and goes to infinity. All right, so you're going to pause and you're going to find the inverse and then state the domain and range of the inverse. Okay, welcome back. So the inverse, we're going to switch our x and y. So we have x equals 3, absolute value of y plus 2. And to find your inverse, you're asking yourself, what do I need to do to get y by itself? Well, first, I have to subtract 2. Second, I have to divide 3. And third, I have to take the square of all of this because it's all there. Okay, so there's my inverse. And the domain of my inverse comes from the range of my original, which is 2 to infinity. And the range of my inverse comes from the restricted, not restricted, well, the domain, it's my restricted domain of this function, which is, sorry, what was the domain here is the range here. Forget the word restriction. Don't know why I said it. I need food, sleep, nap, probably. Okay, then last one. Again, we have another square root. So we don't have a vertex, but we do have a starting point. This time, we have our positive a. There's nothing there, so it's positive 1. And our h is, remember, x's are liars. So it looks like it's a positive 5, but it's actually a -5. And there's no k, so it's plus 0. So we start here. So therefore, our domain is from -5 to infinity. And our range is from 0 to infinity. All right, so we're going to pause and I'm going to let you find the inverse. Okay, welcome back. Your inverse, we're going to switch our x and our y. So we have x equals the square root of y plus 5. To get our inverse, to get y by itself, the first thing we have to do is square. Then the last thing we're going to do is subtract 5. So our inverse is x squared minus 5. The domain of our inverse comes from the range of our original, which is 0 to infinity. The range of our inverse comes from the domain of our original, which is -5 to infinity. And bam, that concludes our section on inverse. If you have questions, let me know. We will go over the classwork. Well, we will do the classwork when we come back after spring break. So don't worry about doing any of the classwork. Enjoy your spring break. Be safe, have fun, and make good choices.